Welcome to the second lecture in the lecture series on graph coloring. So, continuing from the introductory lecture where we started mapping a problem to the domain of graph coloring. So, we were talking about 4 states in a country and we have to paint each of the states in the map in such a way that no 2 adjacent states have the same color in the map. And what we did was, first we represented the states in the form of vertices in the graph. So 4 vertices, S1, S2, S3 and S4, and then the common boundaries they share as the edges of the graph. Now we also started coloring the different vertices of the graph, which in turn will actually mean the coloring of the states in the map. And we started with the S1. We had a color for S1 as green. Now we check the adjacency of S1. So S2 is adjacent to S1, S3 is adjacent to S1, S4 is also adjacent to S1. So actually all the other 3 vertices are adjacent to the vertex S1. So we cannot use the color green for any of these 3 vertices. Now we move on to the next vertex, which is S2. We see that S3 is adjacent to S2, but S4 is not adjacent to S2. So what we can definitely do is we can use the same color, which is violet, for the S4 also, and we can paint this vertex as violet. Now we come to the S3. Obviously it cannot be painted green because it is adjacent to S1. It cannot be painted violet because it is adjacent to both S4 and S2. So we have to use a different color, say yellow, for painting the vertex, for coloring the vertex S3. So what do we see here? We have the color green assigned to S1. So S1 is assigned a green. That's the first thing we see. Then we see that S2 and S4 are assigned. So S2 and S4 are assigned violet. Okay, I'm sorry, this is S1. So I just write S1. And then the vertex S3, we map the color yellow. Okay, so now I am done with coloring the vertices in a way that no 2 adjacent vertices have the same color, right? In short, what we can, in mathematical language, what we can say is, what we have done is we have created a map C such that we have for every vertex a color mapped from the set S, which has 3 colors, red, violet and yellow, in a way such that the color of vertex V is not equal to the color of vertex W, where V and W are adjacent vertices. Okay, so this is the short and simple mathematical representation of graph coloring. I hope I'm able to make you understand with this simple problem how to effectively use the concept of graph coloring. Now let me talk about one more problem, which is also simple but completely from a different domain. Okay, let's consider 5 students. Okay, I have 5 students. Their name are Sachin, I have Saurav, I have Rahul, I have Virat, and I have Lucky. Okay, I have 5 students in my class. Now these 2 people, Sachin and Rahul, they are kind of best buddies. They talk with them all along. So I cannot make them sit in the same row of the class. I have to make them sit in different rows so they cannot talk. Same thing applies to Saurav and Virat and Lucky. So whenever they also sit together, they keep starting talking within each other. And then I have Sachin and Virat also, whenever they sit together, they start talking amongst each other. Okay, so rather I have 3 talkative groups in the class. This is the group 1, this is the group 2, and this is the group 3. I have 3 talkative groups in the class, and I have to come up with some way to make them sit in different rows of the class so that they are not able to talk with each other. How do I do that? Okay, so first I try to map these 5 entities, Sachin, Saurav, Rahul, Virat and Lucky, as 5 vertices of a graph. So I have one graph for Sachin, I have one graph for Saurav, I have one vertex for Rahul, I have one vertex for Virat, and I have one vertex for Lucky. I have 5 vertices in the graph. Okay, now what I do is I try to figure out who talk with each other and try to map that relationship as an edge. So Sachin and Rahul talk amongst themselves. So I draw an edge between Sachin and Rahul. I also see that whenever Saurav, Virat and Lucky, they sit in the same row, they keep on talking with each other. So Saurav, Virat, Saurav to Virat, Saurav to Lucky, and Lucky to Virat. I draw 3 edges, right? Because they keep on talking amongst each other. And Sachin and Virat, they also talk with each other. So I draw an edge between Sachin and Virat. So basically Sachin Rahul is the group 1. Okay, I can name this edge as group 1. Then this is group 2, so I can have 3 edges, group 2, group 2 dash and group 3 dash. Group 2 double dash. And then I have this one as a group 3. Okay, so this is my graph. Now I try to find out labels or colors for each of the vertices so that none of them who are adjacent to each other or who talk with each other have the same color. Okay, so I start with Sachin. I paint this vertex as violet. Okay, now there is adjacency between Sachin and Rahul, Sachin and Virat, but no adjacency between Sachin and Lucky, right? So I can also paint this as violet. Okay, now I can also try to paint Saurav as violet, but since we have already painted Lucky as violet, I cannot paint Saurav. So one of them I can paint as violet. Now Saurav, I have to assign a different color. I assign a color yellow. So this is what I give to Saurav. Saurav to Rahul, there is a connection, or there is an edge between Saurav to Virat and Saurav to Lucky, but no adjacency, or there is no edge between Saurav and Rahul. So I can paint both the edges as yellow. Right. Now I can not paint Virat as violet because there is adjacency between Sachin and Virat and Lucky and Virat. I cannot paint Virat, the vertex representing Virat, as yellow also because there is adjacency with Saurav. So I have to use a different color, say red, for Virat, right? So now I have all the vertices painted with the different colors. And what are the different sets are? First is the violet. So violet, so Sachin and Lucky. Sachin and Lucky, they are painted as violet. We have Saurav and Rahul painted as yellow. Saurav and Rahul painted as yellow. And I have Virat painted as red. So Virat painted as red. In other way, I have been able to label each one of them with a different color, and these different colors now represent the different rows that they can be seated in. So Sachin and Lucky can be made to sit in one row, which is a violet row. Saurav and Rahul can be made to sit in another row, which is a yellow row. And Virat has to sit in a third row, which is the red row. Okay, so this is the way we can find out in a very optimal and easy way how to have the different students sit in the different rows based on whether they talk with each other or they don't talk with each other so much. So this was the second example which I wanted to explain to you so that you understand the concept of graph coloring very well. Now what you have noticed, I'm sure, is we always try to use minimum number of colors when we are doing the graph coloring. Why is that so? Because we're using the minimum number of colors. We want to paint the graph so that there is an optimality reached. Optimum number of colors with which we are able to differentiate between each of the vertices. So this minimum number of colors is called the chromatic number of a graph. So this is called the chromatic number of a graph, and this is represented by chi of G. If the graph is G, it is represented by chi of G, and it's called the chromatic number of the graph. Obviously, what you can definitely do is instead of using the minimum number of colors, you can use more colors. Say, for example, I can use a completely different color for say Lucky. I can paint him with a green also, and that also will maintain the same property that no two adjacent vertices will have the same color. So we can always use number of colors more than the chromatic number. That is always possible. And when we use k colors and k is more than chi g, we say that the graph is k colorable. Okay, so whenever k is greater than chi g, it's called k colorable. So I will pause at this in this particular version of the lecture. In the next lecture, what I will explain is I will start with the different theorems related to the chromatic number, and I will first, in the next lecture, I will cover the basic theorems and the theorems related to the lower bound of the chromatic number. Thank you. Stay tuned.